a pendulum, and I'm going to pick this bottom level right here to be my reference point. So as I pull the pendulum back, and we're up at this position, is it away from the reference point? Yes. So does it have potential or kinetic? I haven't let go yet. Potential. Okay. So up at that highest point, before I let it go, it has all potential energy. And then I'm going to let it go, and it's going to swing down. As it's swinging down, what happens to that potential energy? Is it getting bigger or smaller? Good, it's getting smaller because it's approaching the reference point. So that vertical displacement between here and here, that amount is actually decreasing. Is it speeding up or slowing down? Speeding up. So that means our kinetic energy, because it's going faster, is actually increasing. So as it swings down, potential decreases, kinetic increases.
Is there a point where there is like potential 0?
Yep, good. That's going to be the next one. Okay. So right here, I'm at the reference point of 0. So remember, our potential energy was mass times gravity times height. If I don't have a height right there, and the height was 0, then you don't have any potential energy. So once it swings down and it reaches that point where we said the height is 0, that's our reference, you don't have any potential energy there. But is it still moving at that lowest part of the swing? Yes. So what kind of energy does it have? Kinetic, good. Bless you. Oops, sorry. So we lost all of our potential energy, but it turned into all kinetic. So it's exchanging one for the other. So I did work against gravity to lift my pendulum out to here. It has all potential energy, and then as it swings, the potential decreases and the kinetic increases until it turns into all kinetic energy. It's the same amount as what you start with, it just switches from one kind to the other. And then what about when it swings back up? Is it still moving?
Are they even?
Yes. So if they're going to be even, okay, that kinetic energy, is it speeding up or slowing down as it swings up? Slowing down. So kinetic energy does what? Good, decreases. Okay. And then what's happening to the potential? Good, it's increasing. And then once it reaches that highest point, even with the other side, it's turned back into all potential because it actually stops for that brief moment before it turns back around. So we're keeping the same total amount of energy the whole time. It's just switching back and forth between potential and kinetic. And the little wrecking ball over on the side, we're going to practice with that one. Yep. Okay, so on the next one, we've got this little guy that springs up. So I do work against the spring to push him down. I always mess that up. So I push it down and then wait. Eventually.
Wait, can I see that?
I do work against the spring, so it now has a type of potential energy. Do you know which of the 6 types? Good. Elastic. Okay, so I did work against the spring, so it has elastic potential energy. And then as it's coming up, it switches to kinetic. So there's going to be your transformation. You do work against the spring. So it has elastic potential energy that comes from the work that you give it. And then as it flies upward, it's got kinetic. And then while it's up in the air, it's got gravitational potential energy because it has to have the potential to fall back down, which it does. And then it changes back into kinetic. And then we're gonna omit the fly ball because it's just like the pendulum, but it's upside down.
That's why.
Yep.
What if like the pencil is just sitting here, it doesn't move, is that potential energy?
It depends on where your reference point is. So if you said the reference point's the ground, then yes, because you would have had to lift it to get it to your desk. But if you just start right there and you said that the reference point's your desk and your pencil's sitting on it, then it doesn't have any potential energy.
Okay.
And on your test, I'll be specific and tell you, like, if it's the ground or the ceiling, I'll pick a reference point for you. And then on this one, I don't know if you ever did this before when you were little, and don't hurt each other, but if you have a metal ballpoint pen, you can do it with a paper clip. If you have a metal one, you can bend it back and forth, or a coat hanger, bend it back and forth until it breaks. Or take the tip of a ballpoint pen. You have to hold it kind of sideways so that the metal is actually rubbing, and rub it back and forth on like a folder or a binder or a book. And then if you do that a whole bunch and create a bunch of friction and then touch the back of your hand, you can ask Joey Berenberg what happens.
Does it shock you?
Not quite shock. It burns. It gets really hot. Not that you want to burn yourself, but if, so probably. As long as you use the metal part and you go back and forth really, really, really fast and then touch the back of your hand. I think it works better on like notebooks and paper though. Okay. So you can try that. Can you feel it? Did it get warm? Okay. So if you did it correctly, it's going to start to get warm and you'll actually feel it, the tip of the pen or the paper clip or coat hanger, whatever you're using, it's actually going to get hot. And if you're really good at it, it leaves a little red welt on the back of your hand. I don't recommend that. Okay. But where does that heat come from?
Friction.
Good. Okay. So you did work against friction and it turns into heat. And so the last part, there is a number 5 at the bottom of the section. When we first talked about work, one of the definitions, it said you might see work being defined as energy being transformed. And this would be an example of that case. So if you do work against friction, that work is transformed into heat. Okay, so it's a different type of energy.
Why, when you bend a pen, does it get hot?
It's going to be the same thing. There's friction in the molecules as you're bending it between each other.
Okay.
So they're rubbing up against each other. They have the friction, and anytime you have that, it turns into heat. Anything else? That's it for today.